Good morning, everyone. Today we are going to do a new topic, electrical power. So in this topic, we are basically learning how does the relationship between mechanical energy and electrical energy. So the first thing we're going to learn is how do we transform mechanical energy? Well, basically, how do we transform electrical energy to mechanical energy? Okay. This is basically how an electrical motor works. Say if I connect a motor with electricity, it will spin. And this is a transformation. Okay. Just remember, we need to be very clear with the terminology. Transformation is how energy transformed its form. Before before the energy is in the form of electricity. After the energy is in the form of mechanical. So I gave you an example here. Will be say electrical motor. Now after that, we're going to learn basically how do we convert or transform mechanical energy to electrical energy. Okay. So when we do that, we use another example, electrical generator. Okay. Okay, this is the basics. You should already have those formulas on your formula sheet. Because without those formulas, you won't be able to do anything with this topic. Right? So for year 12, this is perhaps the last time that I'm going to go through those formulas. Okay, let's start with the first equation. I equals to Q divided by T. What I stands for current, and it's measured in amps. Okay, so the unit is amps. This means, okay, and Q stands for the charge. Okay, its unit is coulomb. Start with lowercase c. Okay. C stands for coulomb, not charge. Q stands for charge. Okay. And T will be time, okay, measured in seconds. E stands for energy. R measured in joules. R stands for resistance, okay, measured in ohms. And P stands for power. Okay. Power is the unit of power is watts. Okay. It means joules per second. Okay. Now, so amps. Okay. So look at this equation. 1 amp. Let me put down. Sorry. Okay. Let me put down some numerical values so it makes sense. Okay. So 1 amp of current means 1 coulomb of charge per second. Okay, per second. So yes, if you forget what does charge, what does 1 coulomb mean, just remember that. Okay. 1 coulomb of charge is basically the charge carried by 6.25 times 10 power of 18 electrons. Okay. Remember, 1 coulomb of charge, 1 coulomb does not equals to this much of electrons, is equivalent to the charge carried by this much of electrons. For now, well, you can understand as 1 coulomb is this much of electrons, but just it's a wrong concept. Okay, you can use it in calculation, but just remember 1 coulomb is basically the electrical charge carried by this amount of electrons. Now, on your cheat sheet, one more important thing. Also write down that one electron, a single electron, carries 1.6 times 10 power of minus 19 coulomb of charge. Okay. So make sure you have both values in on your formula sheet so you know how to use them. Now, the next thing will be voltage. Voltage equal to IR, so current times resistance, but more importantly in this case, voltage is also equivalent to energy divided by induced divided by charge in coulomb. So 1 volt is basically equals to 1 joule of energy per coulomb. Okay, so if you have a battery 1.5 volt, it means that every coulomb of electrons, every 6.28 times 10 power of 18 numbers of electrons, the charge of them carries 1 joule of 1.5 joule of energy. So it's the energy carried by those much of electrons. Basically, to make it simpler, it's the electrical energy carried by those amount of electrons. Okay. Yep. Now, the next part is your energy. So, if we times voltage and charge, you have the energy in joules. Okay. Also, if you times voltage, current, and the time, you have the energy in joules. Also, if you times the power and the time, you have the energy in joules. Power is measured in watts, okay, or joules per second. Okay. So 1 watt of energy is basically 1 joule per second. So similarly, you have the equation power equals to energy divided by time equals to VQ divided by time equals to VI. Okay, VIT divided by time. Also, you have I squared times R, or V squared divided by R. R stands for resistance in ohms. Okay, so make sure you have this on your formula sheet, and this is extremely important. Now, the other important thing, if I can show you, we talked about it in year 11. Just say if I have a wire and there's a current moving from A to B. Okay. What this means is at this time the current moves from the positive to negative. However, the electrons moves from the negative to the positive. Okay. Just remember, an electron has the opposite direction as the current. So this is a really important piece of information.